All right. So here we're talking all about solving quadratics symbolically. There are three different methods. The first one is by factoring. In order to use the factoring method, you have to know your multiplication facts. You need to be strong in multiplication and be able to identify values and know quickly what goes into what. You'll see me do that in a minute, but not everything is factorable, so it doesn't always work. You also can solve by the square root property. This will only work if there is no b value. If that bx value just is, it's not there. The quadratic formula, however, works all the time. The downfall of the quadratic formula is that you have to actually memorize a formula. It won't be given to you on the test. You have to know it. The expectation is that you already know it because it's a component of Algebra 1 and Algebra 2. I will show you how I memorize it. It's really stupid, but I will show you how I memorize it, and maybe that will help you. Let us get started by factoring. So example 1 says, solve the quadratic equation by factoring. The way that I like to do this is I like to set this guy up equal to 0. So the first step is set equal to 0. So 2x squared plus x, that 3 has to come to this other side so that it can equal 0. So subtract 3 and set it equal to 0, just like that. Okay. All right. Now, in order to factor this, we're going to use something called the AC method. Identify A, B, and C. What you're going to do is you're going to multiply A and C. And then we're going to use B. So in this case, A times C, 2 times -3 is -6. B is 1. And we put that in the big old X. That's why we call it the X factor. We want to look for two numbers that multiply to equal -6, but add to equal 1. Can you think of any numbers off the top of your head that multiply to equal -6, but combine to equal 1?
-2 and 3.
-2 and 3. -2 plus 3 is 1. -2 times 3 is -6. Some people love this part of math. That would be me. Because I love multiplying and just figuring things out, and it's so much fun. But if you're like, what? Don't worry about it. Use the quadratic formula, okay? When I see this -2 and 3, I'm like, yay, we got our little numbers. We're going to use these to replace this b value. We're going to replace the b value with the 2 and the 3. So let's rewrite our problem. But instead of putting plus 1x, we're actually going to write -2x plus 3x. Because -2 plus 3 is still 1. I'm just rewriting it in a way that makes my life a lot easier when it comes to factoring. If you don't if you remember this, you kind of remember, oh, that was fun, but you need practice. iExcel.com has a lot of practice for factoring. So you can make a little trial account and just practice factoring all that you want. Okay. Now, because I rewrote it in a special way, I can now factor by grouping. Group these two together and you say, what do they have in common? They have 2x in common. If I remove 2x from 2x squared, I'm just left with x. If I remove 2x from -2x, I'm left with -1. What do these next two have in common? Well, they have 3 in common. If I remove 3 from 3x, I'm left with x. And if I remove 3 from -3, I'm left with -1. Now, this is where checking comes in. If you got to this point and the things in parentheses are the same, that means you did it right. So now when we look at this whole problem, this first term and this second term both have an x minus 1. If you remove it from the first term, you're left with 2x. If you remove it from the second term, you're left with 3. And that's how this second term comes about. And these are your factors. Now, the thing is that you're saying this times this equals 0. The only way two things multiplied are going to equal 0 is if one of them is actually 0. That's called the zero property. Zero product property. Take this and set it equal to 0. Take this and set it equal to 0. So if x is 1, this thing will be 0. If x is negative 1.5, this thing is 0. So my solutions are x equal negative 1.5 and x equal 1. This is called factoring. Factoring, again, you practiced it for like 3-4 weeks in Algebra 1 and in Algebra 2. You did this a lot. And maybe you forgot, and that's okay. You can still practice it, but that's not a part of college algebra. College algebra assumes that you already know how to factor. So I don't have a bunch of problems for you to practice. So that's why I say IXL is going to be your best bet for practicing that. Now you can verify your answers numerically, meaning actually put this in the calculator and see what you get. Or I love this method and I want to show it to y'all. Graph the first one on graph the left side and then graph the right side. And wherever they cross, those are your solutions. Now you can see that your answers are correct. Wherever they cross, those are your answers. So anytime you want to solve an equation, graph the left, graph the right, wherever they intersect, that's the answer. If they never intersect, there is no solution. Okay. Any questions on factoring, graphing by factoring? All right. Oh, checking symbolically. What does that look like? Well, you just go back to the original question and you see if it holds true. So x equal 1, type it in. Is it actually 3? So that's 2 times 1 plus 1. Well, that is 3. Verified. Okay. 2 times 1.5 squared plus 1.5. Is that 3? Well, let me check my calculations. 1.5 squared is 2.25. Oh, it's negative, sorry. So it's still 2.25. And then you multiply that by 2 and you get 4.5, but minus 1.5. Is that equal to 3? It is. So both of these work, therefore they're both solutions. Okay. All right, now I'm about to solve using the square root property, and then I'm going to check symbolically, and then we're going to look at how you can look at these graphically. Just a second. Okay. Square root property. Remember, you only use the square root property when the bx term doesn't exist. In this case, we have no bx term, so perfect. Let's use the square root property. It's super simple when the bx term doesn't exist. Just add 32 to both sides. We get 2x squared equal 32. Divide by 2. X squared equals 16. take the square root of both sides, x equals plus or minus 4. So your answer would be x equal 4 and x equal -4. Check your work. 2 times 4 squared minus 32. Does it equal 0? That's 2 times 16 minus 32. That's 32 minus 32. It does equal 0. Question marks until it's a check. 2 times -4 squared minus 32. Again, this is 2 times 16 minus 32. We're asking if that does really equal 0. That's 32 minus 32 is equal 0. Absolutely. We got it right. So the solutions here are x equal -4 and x equal +4. This is called the square root property because you can take the square root. Only works when bx is not there or bx equals 0. Okay. Verify numerically when you solve this. Yes, -4 does equal 0. +4 does equal 0. And that's what we have this equation set equal to. So when you graph the left-hand side, you got your parabola. The right-hand side is just y equals 0. That's this line. So that's where they cross right there at 4 and -4. Any questions about the square root property? The square root property is really, really straightforward and easy to do, but it only can be done when your b of x equals 0. Whereas here we go with this quadratic formula. It is your all-time, no matter what the time, go-to. The quadratic formula is broken down into multiple parts. I'm going to tell you, there's a song that says x equals -b plus or minus the square root of b squared minus 4ac all over 2a. I did a horrible job, but it's basically to Pop Goes the Weasel. I don't like that one because it doesn't really help me. But what I learned was there once was a negative little boy who couldn't make up his mind. So he decided to split and go to a square party where he missed out on 4 awesome chicks. And the party was all over at 2 a.m. And that's how I memorized it. Real silly, real ridiculous, but that's what worked for me. Whatever works for you is something that you'll have to figure out in terms of how you want to remember the quadratic formula, but it will not be given to you on a test. Okay. Now, there's a part of the quadratic formula that's super helpful. There's actually 2 parts. -b over 2a. You all should remember that. That's the x value of the vertex. The square root part, that's called the discriminant. We know something about square roots. We know that if you try to take the square root of a negative, you're not going to get a real number. So if this value is negative, there's not going to be any solutions. If you try to take the square root of 0, it's just 0. But if you take the square root of any positive number, there's going to be a positive version and a negative version, which means you're going to have 2 solutions. So sometimes the discriminant is very helpful for us to know how many solutions we can expect. We're going to talk about that a little bit more in just a second. But for right now, let's just use the quadratic formula. This is how you would do it. 3x squared minus 6x plus 2. Somebody please unmute yourself real quick and tell me why I just wrote it like that. Ooh, we don't have nobody, but I forgot we're recording and you don't want to have your voice on there. My bad. So we wrote it that way so that we have ax squared plus bx plus c. When it's written in standard form, it's so much easier to identify your a, b, and c. So that's what we're doing here. A is 3, b is -2, -6, and c is 2. So when I substitute that into the quadratic formula, I got -6, that's the b, plus or minus the square root of b squared minus 4ac all over 2a. So this is 6 plus or minus a square root 36 minus 24. Hold on, y'all. It's like somebody beating on my door. Hold on, y'all. I'm sorry. Again. Oh, goodness. Hold on, y'all. We've learned how to do it with the square root property. So the question now is, how do you do it just graphically? All you have to do is graph the left and graph the right. If I graph the left and I graph the right, these never touch. How many solutions would that be? No solution. Now, how do we know that? Let's look at that discriminant one more time. B squared minus 4AC. The discriminant here, there's no B value. So it's 0 squared minus 4 times 1 times 1. This would be -4. The discriminant is negative. When you take the square root of a negative, no real solutions. Right here, you graph the function, and then you graph the right-hand side. They touch barely right there. So that's one real solution. How do we know that it's really only one solution? Well, let's look at the discriminant. B squared minus 4AC. That's going to be 8 squared minus 4 times -1 times -16. That's 64 minus 64 equals 0. The discriminant is 0. When you take the square root of 0, you just get 0. You can't plus and minus 0 and get something different. So therefore, we only have one solution. And last but not least, you graph the function, and then you graph the right-hand side, which is just y equals 0, and they cross twice. What does that mean? Two real solutions. Let's verify with the discriminant one more time. In this case, it would be -6 squared minus 4 times 2 times -8. So that'd be 36 plus, because -4 times -8 makes a positive 32 times 2, which is 64, which is 100. You take the square root of 100, you're going to get plus and minus 10. Therefore, there are going to be two real solutions anytime the discriminant is positive. So the discriminant is just a way to show how many real solutions there are. Put a star by number 7 because there will be an example like this on your test. The question is, how many real solutions? You're going to have to say, what is the discriminant? I'll show you real quick again how to use it. B squared minus 4AC. Put in the B, -4 squared, minus 4 times 5 times 4/5. That's going to be 16 minus the 5 and the 5 times 1/5 is already going to cancel, so I'm going to get 16. 16 minus 16 is 0. That means that there's one real solution. That's it. Here, I'm going to do this again, but I'm going to write it in standard form first. So then when I do B squared minus 4AC, I know that it's 5 squared minus 4 times 1 times -4. That's 25 plus 16. That's 41. That's a positive number. So we're going to have two real solutions. Now, if I gave you one that was 0 and I gave you one that was positive, I'm pretty sure this one's going to be negative, just so that we have an example. But let's actually do it. So In order to do this one, you need to know your A, B, and C. And it's not as easy as just looking at it and figuring it out because it's in vertex form. So we actually have to solve this by factoring everything out. So -3 times x plus 5 times x plus 5 minus 6 equals 0. X plus 5 times x plus 5 is x squared plus 10x plus 25. And you might ask me, how do you know that, Dr. Taylor? Because I know how to factor and how to multiply binomials. So x plus 5 times x plus 5. A lot of you are familiar with FOIL. That'd be x squared plus 5x plus 5x plus 25. And when you combine like terms, you get 10x in the middle. That's the stuff that I need you to remember from Algebra 1. Like, I can't really take the time to do it in college algebra, but I can, of course, give you some resources for it. Okay. Once you do that, you're going to distribute the -3. So you get -3x squared minus 30x minus 75 minus 6 on the outside. Put these two together, you get -81. And now we can use the discriminant. B squared minus 4AC. B is -30. A is -3. And C is -81. Long story short, we're going to get 900 here. And we're going to subtract still because there's 3 negatives. This is 972, which leaves us with a -72. And because our discriminant is negative, can't take the square root of a negative and get real numbers, so we get no real solutions. Some of you might be like, "Ooh, that's a lot." Yes, it's a lot of algebra. And because we're in college algebra, the assumption is that you feel super comfortable with that algebra. That might not be a reality, and I understand. Let me know if you need practice on this stuff. The new stuff in this is, honestly, none of this is supposed to be new. But the big review part is just knowing that if the discriminant is negative, there's no real solutions. If the discriminant is positive, there are 2 real solutions. If the discriminant is 0, then there's only 1 real solution. Okay. Find the domain of the function and write your answer in interval notation. Remember, this was one of those things, like I said, if you don't remember anything else I said, remember this. The only restriction to the domain is if there's a denominator or if there's a square root. You cannot take the square root of a negative, and you cannot divide by 0. So in this case, we have a division symbol. So this cannot equal 0. Well, how do you solve this? You can use a quadratic formula, or because there's no BX value, you just use the square root property. Add 9 to both sides. X squared equals 9. Take the square root. X cannot be plus or minus 3. So if X was 3, this would make the denominator 0. If X was -3, it would make the denominator 0. So the domain for us is all numbers except -3 and 3. We learned the first week of class how to write that. Negative infinity to -3, -3 to +3, and 3 to positive infinity. And there you have it. Now, this is the takeaway from this whole lesson in this box. To use factoring, you must be able to factor the expression. You're never going to know if you know how to factor an expression unless you try. To use the square root property, there cannot be a BX value. But you can always use the quadratic formula. So if I were to memorize anything, it'd be the quadratic formula. Let's do these last 2 problems and then class is over. Okay. The height of a rock t seconds after it's being dropped can be represented by this formula. Find h of 1.5. So 1.5 is going to be after 1.5 seconds, a second and a half. How high is the rock off the ground? So h of 1.5 is equal to 96 minus 16 times 1.5 squared. All you have to do is put that in the calculator. You don't got to sit with that for a long time. Oh, excuse me. You just do what you got to do. So open your calculator and let's do it. 96 minus 16 times 1.5 squared. I get 60. What that means, interpretation, don't forget that part on your test. Some of y'all did not interpret your answers. That's important. After 1.5 seconds, the rock is 60 feet in the air. Okay. How long does it take the rock to hit the ground? So when is the height equal to 0? When is the height equal to 0? Well, we just take that thing, 96 minus 16t squared, and we set it equal to 0. And because there's no b term, we can just use the square root property. So subtract 96 from both sides. Divide by negative 16 on both sides. 96, negative 96 divided by negative 16 is just 6. Take the square root of both sides. The square root of 6 is 2.44. That means the rock hits the ground after 2.44 seconds. Now notice that the answer is really plus or minus 2.44. But negative 2.44 seconds means nothing. So we're only interested in the positive. Because what would it mean for it to be negative 2.44 seconds? Like that doesn't exist. You can't go back in time. Last problem. We have the height of a soccer ball in meters can be modeled by this equation, where x is the horizontal distance the ball traveled. So our output is going to be the vertical distance or the height, and the x value is how far it went out. So if the ball is kicked, what is the height after 25 meters? So the ball is kicked 25 meters out. What is the height? Just plug in 25. Okay. Negative 0.01 times 25 squared plus 0.6 times 25. I got 8.75. Anybody else get something different? Okay. It says find the height, I'm sorry, find the distance it was kicked when the ball actually is back at the ground. So we're gonna set this equal to 0. So we're gonna say negative 0.01 x squared plus 0.6x equals 0. And this, unfortunately, is not a square root property, and we probably could factor it, but we'd have to multiply it by some things. So I'm gonna try to factor it real quick. Take this whole thing and multiply it by 100. The reason why I multiplied it by 100, because I don't want them decimals. So if I multiply this first one by 100, it's just gonna be -1. And if I multiply the second one by 100, it's just gonna be 60. Okay. And so I can factor out a -1, and I'll have x squared minus 60x equals 0. And then I can basically factor and say, can I factor out an x? And it's saying that x is 0 or x minus 60 equals 0, which would be x equals 60. So those would be our the answers for when h of x equals 0. Now it says interpret your answer. That means that when the ball is not kicked at all, the height will be 0. But once the ball has traveled 60 feet horizontally, it will be and came all the way back down to the ground. After traveling 60 feet horizontally, think about you kicking a kickball. The ball has traveled already 60 feet horizontally. That means the ball will be back at the ground. That's it. Any questions about that one? Okay, y'all. So that's 3-2. Tomorrow in class, we're gonna go over 3-4, 3-5.